starting.
We already did this.
Oh, 7-3 day one. All right, good call, Ashley.
That wasn't me.
Did you have fun?
I'm not that smart.
Oh.
That's me.
7-3 day one. Okay. Guys in the back, focus. Okay, we're still doing hypothesis testing. For population mean. But this time, small samples. And under 30 for normally distributed populations. We have to know that or we can't do it. For normally distributed populations. Okay. When we've got this situation, we've got what's called the t-distribution instead of the standard normal distribution. So this is the t-distribution. Well, before we can do the testing, we've got to learn how to read the t-table for hypothesis testing. We learned how to read it for confidence intervals. Now we're going to be using those other two columns, the one-tail, two-tail business. So the first example is just going to be how to read the table. Those of you that have the IMT can figure that out on your calculator. I think the table's easier, but that's okay. So our first example is going to be to find critical t-values, which they refer to as t sub 0, just like z sub 0. And our first one, the information we need, we are going to go with a left tail test, an alpha of 0.01, a sample size of 14. With those three pieces of information, you should be able to find your critical t-value. So, t-distribution is normal, just that the tails are a little bit thicker, things aren't quite as accurate. So we've got our shaded region in the left tail. There's 1% shaded here. There's 99% unshaded. And we want to find this critical t-value. Are you ready? Not yet. We've got some writers. Okay, you ready? All right. If you look at the t-table, which is one paging on the front cover, t-distribution, somewhere.
Wait, is this the one we already used?
We've used this, yep. Okay. If you look across the top, you've got level of confidence, Keenan. One tail or two tail? What do you think is the situation here? One tail. Level of confidence was the last chapter. You're not going to be looking at those. One tail and two tail indicates how much is shaded. We've got one tail shaded, and I had 0.01% shaded. And this is still degrees of freedom. What was my sample size? 14. So what's my degrees of freedom? 13. So I had to go down to the 13. 2.650. So, 2.650. I'm going to ask you, does that make sense to its position here? No. You have to know to do what? Supply the negative. Because this is a symmetrical graph, you've got to know that the 0 is in the middle. When I go to the left, those are the negative. Okay, those of you with the IMT, my guess is it's going to be area to the left, 0.01, comma, degrees of freedom, 13. So that's what we looked up. Does it give you negative 2.650? If you have the IMT? Yeah. So it's area left, comma, degrees of freedom, and you're good to go there. let's try right tail. Alpha equals 0.05. N equals 9. Okay, so the shaded region is in the right tail. 5% shaded, 95% unshaded. Looking for this critical T. Should this one be positive or negative? Positive, okay. Okay, normally we've been looking up the area to the left, but if you look across the top here for the one tail, because we've got one tail shaded, there isn't a 0.95. So what are we actually looking up? The amount that's shaded in the one tail. So the 0.05, and was it 13 again? Oh, sorry, it was 9, so it's 8 degrees of freedom. Got to go one less for degrees of freedom. So 1.860. Those with the IMT.
They gave us 1.859, like around the city.
Did you put in the 0.95 or the 0.05?
I put in the 0.95.
0.95, yeah. So that program's built for area to the left.
Yeah.
Okay. All right, last one then. One tail, two. Okay, now we got the two tails. And this is the one that gets people if you use the table. But there's two ways to get the answer. So two tails, alpha equals 0.01, n equals 16. So we got some shaded on the left and some shaded on the right. How much is shaded in each part? 0.005. Cut the 1% in half. So we've got two critical values, but they're symmetrical. One's positive, one's negative. Like I said, there's two ways to look this up on the T-table. You ready? Okay. Because I do have the option of two tails, I can look up the total shaded area for the two tails, which was 1%. How many degrees of freedom was there going to be? 15. So if I go down to the 15, I got 2.947. But I used the two-tail row with the full 1%. Okay, what was it again? 15? 2.947. So this is negative 2.947 and positive 2.947. How else do you think I could have gotten one of those values? Under the one tail. If I look at one tail, 0.005 and 15 degrees of freedom. One tail, 0.005. Well, how many degrees of freedom? Why do I always keep forgetting that? 15. The same thing. Yeah.
So the detail part of the chart already takes into account if I split it up.
Yep. So it wants the total for the two tails. So don't mess it up. Everybody good? Reading the T-table? Okay. Now it's all the same. The process to doing the by hand stuff, we're only going to do one today. So I think they're that easy. So, to turn your sample value into a T-score, it's the same thing we did on Friday. You take your sample, you subtract the population mean, divide by the standard deviation over the square root of the sample size. Nothing different. see what claim we're making here.
Example?
Yep, an example.
Is that just like the formula then?
Yeah, that's the formula we're gonna use to turn our sample mean into a t-score. It's the same as getting a z-score. It is no different. All right. Let's go with try it number 4. Let's see, an insurance agent says that the mean cost of insuring a 1995 Ford F-150, oh, this is nice. Mean cost of insuring a 1995 F-150 is at least $875. You are going to sample 9 F-150s. They had a mean cost of $825 with standard deviation $62. Test the claim at 1%. Assume insurance costs are normally distributed.
Does it have to say the insurance cost are normally distributed?
It has to tell, if it's a small sample. If it's a big sample, then it doesn't matter what the population distribution is. Anytime it's small, it has to come from a normal, or the statistics don't mean anything.
So if it doesn't come from a normal,
Just they can't do. They'd have to have a bigger sample. Okay, same 5 steps we did on Friday. What was the very first thing you do on every single one of these? Write the pair of hypotheses. So rewrite the claim and symbol. The claim is about the mean cost, or the average cost of insuring. So the symbol is mu is at least greater than or equal to 875. The hope, the ha is less than 875. Okay, now what's next? Draw the graph. Normal graph, shading, which one? Why the left? Because the ha is pointing to the left. There we go. How much is shaded? 0.01. Now we find our critical value. What options do we have for critical values? What could they be? Z's, T's, or Chi's. How do I know? Sample size. This symbol and sample size. This symbol, I'm down to Z or T. This tells me T. I want a critical T value. So you can use your T or the T table. Go ahead and look it up.